3. Okay, good morning, good evening, good afternoon, anyone. Thank you for watching our YouTube live stream session, this time with Markus Ehrenmüller from all the way from Austria, from not exactly Vienna, I guess somewhere close to Vienna. He would explain it
Yes.
for sure. And he's here to talk with us about the AI features, the easy to use AI features in Power BI, which we are delighted to hear it. And it is his 9 p.m. over there. So really appreciating the time that you are giving to us, Markus. And just one more thing, if you have any questions in the middle of the presentation, just feel free to put it in the chat window over there. We'll get back to your questions in a specific points of time through the presentation. So over to you, Markus.
Yeah, hi, welcome. Also, good morning, good afternoon, good evening, whatever time it is. Thanks for joining. I will start to share my screen, I guess. It's a good point now. Welcome to my, and remove this one. So, Reza, can everybody see the screen now?
Yep.
Just let me know.
We can see your screen.
Okay. Yeah. Welcome to my talk about self-service AI features in Power BI Desktop. So, the idea is to enrich your business intelligence with artificial intelligence. The agenda is full of many things. As I started with this talk like a year ago, there were a couple of features, and it's really fun to see that those features are getting more and more and enriched. So I already did this talk several times, and every time it's a little bit different because I pick different features which I think are really nice to see. We will see the Q&A feature, question and answers, the quick insights feature, the what if parameter, the analytic line, the R integration and Python integration. I think it's still missing here, but I will show you some of Python code, cognitive services, Azure Machine Learning Services. There's a lot of features I have prepared. There's even more, and yeah, let's see how many questions are there and how fast I talk. So there could be different features I have time for to show you in this 60 minutes. So artificial intelligence, I did not take any academic definition what AI is, but for this talk, I see AI as features which helps you. This could be automagical stuff, like features Power BI is helping you. And I did not think about how it is implemented. Is it really machine learning or artificial intelligence, or is it just programmed as if then else statements? So I did not think about it. And up to machine learning things, of course. So we will see a lot of things. We will see things you can do in the GUI, the graphical user interface, without any code. And we will see some codes like in DAX, in M, and in R, and Python. I guess that I will have time for that. So I hope that for everybody there's something new and something enlightening and something you can learn from, no matter of which level you're currently in AI or in Power BI. This will lead me to the demo, and I will not leave demo mode until the end of the talk. So maybe 50 minutes, 55 minutes, depending on if there are questions at the end or if I do the whole 60 minutes. So now stop for slides for a moment for the rest of the time and go over to Power BI. Power BI Desktop. So we have Power BI Desktop here, and I loaded the AdventureWorks database into it. I prepared some stuff there, and of course I will share the file so you can play around with everything I will show you. And most of the things I will show you can see down there is a lot of slides, reports already down there. So this is like the solutions of the examples I will showing you, so you can see and train and learn on your own afterwards. The first thing I want to show is Q&A. Q&A is the feature that you can double click on the pane. If I double click there, this window appears and tells me ask a question about your data. So I can type in what questions I have. It's also coming up with automatic questions, which the system Power BI thinks which could be interesting. For the moment, I'm ignoring them, and I just asking for sales amount. And then I get this blue underline and suggestions of what I can use. So it understood what I meant. And if we get rid of this box here, we can see the sales amount everybody is working with. AdventureWorks knowing that for the reseller sales, the whole sales for the whole model is 80 million. So this is what I'm getting without any finding the fields there or asking for a certain type of visualization. It's coming up with the number, show me the number. And I can continue. So for example, by category. When we can see that sometimes it does not understand it, and then we get 2 red lines, and then I'm finished, and it understands it, and it's coming up with a representation of my product categories: bikes, components, clothing, accessories. And I really find this is really nice, so I will keep this. When I first saw the Q&A feature, I thought, yeah, this is nice to impress people new to Power BI, but who will use this feature? I mean, typing in stuff. And I discover more and more myself that I really miss the feature if it's not available. Like if you're using Power BI Report Server, the feature is not available. I still do double click and ask for stuff. Sales amount, for example, amount by promotion. Promotion are the marketing actions we are doing. And as long as I stay with this window, as I just press enter, it will the bubble there, the entry field will, the input field will stay there, so I can change it anytime. We can also change it and, for example, ask for 2013. So the Q&A feature is not only understanding entities from my model, so sales amount is a measure in my model. Promotion is again a column in my model, and 2013 is not a column, it's not a table, it's the content for a column, and still will understand and now filter it to 2013. So see this, we can convert this Q&A to a real normal visual. So we're now losing this entry box, but this is now a normal visual. So we can see, for example, that the filter is now applied. Here is in 2013. This is what automatically happens here. And of course, we can now change stuff there. For example, I'm only interested in the promotions. The no discount element is not of interest for me. I could just click there and then exclude the element. So this is a normal visual as if you would have created it the traditional way. So I really like this feature. For the sales amount by, I have now a typo here, sales amount, come on. Sales amount, let me pick this one. Sales amount by territory group, I guess, is the right one. Then should discover that the group, oh, something went wrong. This is not very good. So you see, this is a live demo. Let's see if I cancel, if everything works. Yeah, I'm lucky. So territory group. In the model, I assigned to this territory group that this is a geographical information. That's why Q&A is automatically coming up with a map. I'm not a huge fan of those maps because usually the people I'm working with, they know where North America, Europe, or Pacific lies. Even here, I mean, Pacific is like the Australian region, but it's like spotted here in the middle, more or less in the middle of the Pacific Ocean. And for example, for NA, where it's not applicable, it's pointing it here to Nairobi. So this is why it's getting here. I'm not a huge fan of those maps. Good that they are there, but if you're using them, please do not rely on this automatic feature that the Bing maps are discovering which region you mean. Please always try to get the longitude and latitude of the positions you wanna show, and then use them in the map. To get rid of the map, of course, I could change it to a normal visual and then change it there, or again, I can ask for it. So as a bar chart. Then we get a bar chart. So this feature is not only discovering all my elements in my model, but also applies filters, and I can ask for certain actions. So I can ask for the maximum, minimum. This is a really, really smart feature, I would say. And if you use the sales amount by date, then we should get a line chart, because by date, the feature knows date is a date time thing, and this is continuous, so it's now showing everything on a line chart. As easy as this. This is the Q&A feature. If you've not heard about it, check it out. I really, really like it, and I think I'm way faster in creating visuals with that feature instead of looking for everything in the field section. Of course, there's a search field up there, but then you have to click and mouse track, and I think this is easier to keep my fingers on the keyboard and create stuff there. Let's stay with the sales amount by date for a moment. So if we convert this to a visual, I can put it like there. And there's an interesting thing here. So if you see, of course, it's really volatile. This AdventureWorks has no steady sales, but the sales are going up and down again. And there's like the highest spot here, which I think is interesting. So something happened here. Maybe we can learn from that because yeah, something happened here. We had the most sales. And if you find out why this sales is so much higher than a month before, maybe we can learn something from that. So wouldn't it be nice, like with the Q&A feature, like double-clicking on the pane, if we could ask Power BI to explain what's happening here, to explain the increase. And this is available in the analyze, explain the increase. I zoom in here, so I don't know how good your screen resolution is here. So right click on a point in a chart and then analyze, explain the increase. And if we do this, we get this smart bulb here. So now Power BI is indeed coming up with a model, training a model with the data, and trying to find out what are influence factors to this chart. So why is the number higher? And one thing it came up with, you can see here, so this came up with a lot of different, maybe I zoom out again, so we can see there's a lot of, there's a scroll bar here, and we're going down. I think this is 10 or 12 different charts it's coming up with, different insights. It's also explaining what it came up with. Here's the analysis of the 58 increase in sales amount between December 1st, 2012 and January 1st, 2013. And what I found was that it's Saturday, in December, we had 2.6 million, and in January, we had 4.2 million, and we see a waterfall chart between that. So we see M and F, and what is M and F? M accounted for the majority of the increase among gender. So M is obviously the males. Our male salespersons had a huge increase, and this increase was much more than of our female employees. So now the question maybe is in your brain, is this fair or not? Because if we have more male salespersons, of course the increase is more according to them and not to the females because we have less female sales employees. But what we can do here, we can change this visual. For example, we could have a scatter plot. Don't see any insights in that for this use case, but we can change it, for example, to a stacked 100% stacked bar chart. And then we see that indeed in December, the female salespersons had the majority of sales, so 52%, and this shifted around to the majority of the males 1 month later, 57%, almost 58%. So if you like this, then you can put thumbs up there. I'm not sure what's happening in there. So the model does not take this. Maybe Microsoft is tracking this information to learn about what people liked or what not. But what's really important or nice here is this plus symbol, add to page. So I can click here and add again another visual to my page here. So the first one we created with Q&A. This one we created with Insights feature of Power BI. And then again, this is a normal visual. So we can change, for example, the colors here. I'm a more traditional person. So for the data colors, I would change it to blue, red for the females. And we can add constant line to show everybody that where the 50% is. And then we can see that the majority was in the red area and now the majority is in the blue area. So males, females change from 1 month to the other. And this is a nice feature to share now the insights. So not everybody has to now click there and find the insights and generate the insights, but we can now share the insights, which we found is really useful for everybody. Another feature I want to show here is the what if
sorry
pyramid.
to interrupt just in the middle of this one because we got a question related to this feature from Amit from India. He's asking that can we 100% rely on the chart that is suggested by the explain increase or decrease?
Can we rely on the chart? I don't really get the question. Of course, you can rely.
It is probably meaning that is this visual doing something special, or it is just a slicing and dicing the value by other fields in my table, which if that is the case, then it means that as long as my data is reliable, the visual should be reliable, right?
Yes, yes, it is. Of course, if the data is reliable, also this visual is reliable. And which I did not mention is the list of features is coming up with the list of possible insights. Of course, this is statistical insights, so it doesn't mean that this has real life insights. It could be by accident that the share is like that. If it's useful or not, this is up to us with our domain knowledge. Of course, the system, the machine learning algorithm doesn't have any domain knowledge. That's the first thing. And the second thing is those insights are ordered by statistically significance. So the algorithm behind the scenes is indeed looking for, is this like is the difference between males and females for this month, is the difference bigger than it would be for other features in my model? So yes, you can depend on that. I would say you can trust the thing.
Thank you.
Let's go to the third feature I want to show you. Here I want to show you how we can find out if we should, for example, give discounts to decrease our sales prices. This is a concept of elasticity, but let's build the thing up here. So in the modeling, we have this nice feature saying new parameter. And then we can enter something. Maybe I zoom in here so everybody it's a bit easier to read for everybody. New discount would be that, and the discount should be a decimal number, and it should be from between 0 and 1, and the increment would be 0.1. So we have a percentage, 1%. I don't need any default here, and I want to add this as a slicer on the page. Then we get the slicer up there, and we don't need to refresh there in the background. Maybe I go back to the Power Query and close the Power Query so it's not showing up once in a time. So yes, so we have the new discount here. And then I add another parameter. So new discount now can change between 0 and 1. And we can change this in the new discount here. So the new discount, we can change this to be a percentage number. If you update this, this should then change to a percentage number. And the second parameter I want to use here is the elasticity. So the elasticity, not new measure. I'm still a little bit confused with the new UI, still looking around for the right thing here. So modeling, come on, we don't need this measure. Modeling, and there's a new parameter, and this new parameter should be the new elasticity. I have to make sure that I don't have any typo here, because then later on I will use pre-prepared formulas between 0 and 5 maybe, and the increment should be 0.5. And a slicer to a page, and even if we add a slicer to a page, 0.05, so and say okay, it doesn't really appear. This seems like to be a bug since some versions. So the second parameter is not coming up as a slicer. Again, something went wrong. This is not really good, but it's working. And but this is no real issue, because we can just add this as a slicer, and then I have the slicer here as well. So that's not of a big issue. And then we can, for example, have 2, for example. So next step, I want to show what the sales amount currently is. So sales amount would be here. There should be the sales amount. And I want to show this in a multi-row card. The question is now, if we increase the discount, how would the effect is the prices? Of course, the price would go down by 20%. So we can create a new measure and then I cheat a little bit to avoid too many typos. So let's go here, and there would be the new unit price. And let's make this a little bit bigger for everybody. Paste this in. So the new unit price would be the old unit price times 1 minus the new discount value. So if we have a discount value of 10%, That would mean that the unit price is multiplied by 1 minus 0.1. This is 0.9. So times 0.9 would be 10% less. So add this new measure here, and then we add this measure into our multi-row card here. So this would be the, no, not here. Don't make fun of me here, new unit price. The next thing would be to calculate the new quantity. So what is the new quantity? We would expect if we decrease the prices that the quantity is going up. But there's this concept called elasticity in economics, that the quantity will not go directly up by the percentage, but depending on the price elasticity of the product. So this time, the order quantity is times 1 plus the new discount, but not the new discount purely, but multiplied by the elasticity. So elasticity of 2 means that if I lower the prices by 10%, the quantity demanded by our customers will increase by 20%. That would be is the meaning of the elasticity. What the elasticity is in your case, you have to find out. So ask, for example, you can ask your customers, how much would you buy if the price is like on this level, and how much would you buy if the price is on this level. The easiest thing is then to calculate the new sales amount. So the new sales amount would be, of course, the new quantity times the new unit price. Let's have a look here. So new quantity times new price, quantity times price, that's what usually the sales is. So we get this measure rather easily. New sales amount, let's add it here. And then I add the last one here, that would be the difference. So I want to see how much our change in price would then change our sales amount. So I calculate the difference of the new sales amount minus the old sales amount. So we see, is this a good idea to lower the prices, or is it a bad idea to see the difference here? As you see here, like with 20% discount and elasticity of 2, we see that now we're increasing from 80 to 90 million. This is almost 10 million, 9 million something of increase. So this would be a good idea to increase. And we can really see this if I change the discount. So currently we have a unit price of 300. If I increase the discount, of course, the price is going down. If I increase the discount, also the elasticity is going up. If I increase the discount, the quantity is going up, of course. So 325, I increase this, then the quantity is going up. If I change the elasticity, for example, lowering, again, increasing the, can we move this a little bit? So I'll move this a little bit down. This is confusing. So if I increase the elasticity, the unit price would stay the same, but the quantity would go up. Can everybody see this? How the numbers are changing? So this is this concept. So as I told you, the elasticity, this is like given by the market, by your customers, how they approach your products. Of course, there are limitations to this concept. So if, of course, for example, if milk would cost only a few cents, you would not drink 20 gallons of milk, of course. There's some limitations there. Or for high-priced products, if like Rolls-Royce would like lower its prices and you could buy Rolls-Royce for a few hundred euros, maybe the sales would go down because people have bought the product because of the high price, because of the prestige. Now the prestige is gone with the low price. So of course there is some limitations to this concept, but I picked it because I think it's really nice to understand and to see what you can do with this what if parameter. The question now is, what for a given elasticity is the best discount? So of course we can play around and find out, is this now increasing or decreasing the sales amount? What is the sweet spot? And one thing we could do is to take the new discount. So I take the new discount, all the new discount values, put it on a line chart. And on this line chart, I also put the sales amount difference. And this is rather a boring line chart. Discount should be on the axis. Because currently, we have a discount of 22%. And of course, for 22%, is this working? This is not working. Discount value, let's put this on the axis. What's happening here? So discount, new this, not this one. Yes, this one. So here's the discount. For 23% of discount, we have a sales amount difference of 12 million. So what we're seeing here. So this is a line chart, but only for one data point, and therefore it's not really a line chart. It's just showing one point. A little bit boring. Why is it only showing one value? Because of the feature in Power BI, the cross-filter thing. So if I have selected something in the slicer, all the other elements on the screen are filtered by the slicer. And lucky enough, we can influence this. So I can click on this, and under format, I have the edit interactions. So I can change if this element is interacting with all the others. So we get those nice symbols in here. And usually it's filtered, but I can just change this to do not filter this. So the new discount is not filtering this line chart. So we get a line for all the possible the possible percentage values. So we get rid of the point, and now we see like this is this curve, and the sweet spot is somewhere there. Is it easy to spot it? We can support this again with the line chart here. We can have a max line, add a max line, and for the max line we can add a data label. So then we can see that 12,370. So we're close to the best thing is. Can everybody read this? Unfortunately, I cannot increase the font size still here. So 12.37 million would be the highest difference for the given sales amount, for the given elasticity. The question is, what is the discount percentage for that? And we can answer this again with a little bit of magic in DAX. So again, I come up with a new measure. And again, I'm cheating. I'm not typing this for your sake. Otherwise, you would watch me in writing typos and correcting the typos. So the first thing we get in here is the, did not work, copy again. Come. That's a noise I do not want to hear. So a new measure and not edit the existing, but give a new measure. Here we go. So the max sales amount difference, so the maximum of the sales amount difference, I'm calculating with this iterator. So the iterator, the x, all the functions, or is it all the functions? I'm not sure, but there's a lot of functions having an aggregator there and then an x at the end, like max x. This is not a typo. Max x is the name of the function. Sum x or min x or average x, and I think there's also product x. Is an iterator. So that means I'm passing in as a first parameter a table. In this case, I'm not putting in a table, but an expression, a function, all, which is returning a table. This is also valid. And all makes sure that no matter if there's any filter applying to this measure on the new discount, I'm ignoring it. So I do not have to turn off this interaction thing, but I'm turning it off in DAX, all new discounts to get all the possible discount values from 0 to 100, from 0 to 1. If you remember, that's the minimum maximum number I told the what if parameter wizard. And then I'm passing in an expression. This expression is really easy. This expression is just the new sales amount difference. So it's now evaluating the new sales amount difference for all the possible values, like here on the line chart from 0 to 100%, and then returning which one? The maximum one. So I get the highest sales amount difference, which is possible with the given elasticity, returned by this measure. And when I put it up there in the corner, here, close this down, and then I put the maximum sales amount difference again as a multi-row card. Then we see this 12.37 million. It's the same number like down there, but now we can actually read it and we can influence it how big it is. And now when we know this number in DAX, it's easy to find the discount for that. So I have another new measure. This time it's a little bit of a long expression. But I think you are glad that I did not type this. And then I paste this here. So the best discount amount is what? I'm using variables here. If you're not used to variables, please check them out. They make, of course, the DAX code a little bit longer because you have to first define your variable and then you use it. So you have more lines of code, but it's really helping you in understanding and reading the code. So I think the readability of the code really increases. That's the first thing. And the second thing, also the performance increases, because for this variable, this maximum new sales amount difference is only calculated once. Before the rest is evaluated, all the variables are evaluated, and so this new max sales amount difference is only evaluated once. Even if I'm referring several times to this variable down there in the code, it's only calculated once. This increases the performance. So I remember what is the max sales amount difference. You know, this is this number 12,237 million of sales. This is the maximum number. And then I'm using again the max. So I want to find the max discount in this case. First parameter is again a table. Which table? In this case, I'm not putting in it all, but I'm putting in the filter expression. And for the filter expression, I again have a table here. The all discounts, for all the discounts, now they are filtered. So I don't want to return, so this filter expression is not returning all the discounts, but from all the discounts, it's returning the element where this new sales amount difference is the max sales amount difference. So that's the maximum number. So it's only returning one row from my discount table. And from this discount table, from this table, I'm only returning the discount. I'm not returning the sales amount difference. I'm returning the actual discount. And this is the second variable, and that's what I'm returning. So return, if you're using variables, you also have to put the return at the end, and then I'm returning the variable. Of course, I could put in the return statement up there, but usually I'm defining all my variables, and at the very end, I'm returning the variable I'm interested in. So again, press OK here, and then we can add also this element to the multi-row card up there. New best discount amount, and if I'm lucky, yes, 27%, and we make a percentage out of that, then we see 27% should be the maximum, and we can prove that. So can we really trust it? Of course, we can put also 27 in here, and then we should see if we have 27, then the new sales amount is the 12.37 million, and that's what we got with the 27%. So maybe this is the least AI functionality, but I really like it because it gives interactivity to your users, and you can combine this new parameter, this what if parameter, with so many different things. For example, you could change a parameter and inject this parameter then to an R script, an R visual. So you can combine endless possibilities to make all your reports more interactive. So how I'm doing time-wise, just check, half of the time is gone. Let's see the correlation. So now we have, let's see the trend line first. So in the sales amount, when I add the sales amount by date, you can remember this chart. Then we see this really volatile. So sales are going up and down, looks more like a random pattern, but overall, I have the impression that we have an upwards trend. So the numbers at the end in 2013 are higher than in the beginning. So even with this volatility, we have a trend which should point upwards. That's my gut feeling. Can we prove this gut feeling? Can we show the numbers that is really upwards trend? Yes. So one thing I already showed you was this analyze feature. It's a little smaller here, and there's also a trend line available if you're using a line chart. So these features, they are depend on what kind of visual you're using, and with the trend line added, we can see yes, there's an upwards trend going up there. This upwards trend is calculated as a simple linear regression. How do I know it? Because I recalculated it and saw yes, it's a simple linear regression. Can we change this trend line, the algorithm behind it? No, we can't. So we just have to stick with it. If you're good with a simple linear regression, the trend line is your friend. If you're not good with it because you want to change it, you have to come up with your own calculation for that. And that's what we're doing in the next thing. So I'm coming up with a new measure again. And you know me, I'm cheating here. So we are going down there. Where's the DAX measure for the linear regression? Linear regression is here, and this is the calculation for the linear regression. Even longer than the other ones. I put it there, I show you the result, and then I will discuss how this is calculated with you. I think it's easier if you just saw really that this is working and showing the linear expression here. So I add this to my line chart, and by seeing there's one little change. If I add this, come on, add this. There's one little change. I don't know what the reason for this is. So if you're coming up with the reason for this, please tell me. If I create this chart with the Q&A visual, then I always get in troubles that it's showing up the linear sales amount. Either there's some filter, dates, maybe it is. But the sure thing is if I just delete it again and then come up with my sales amount again. So where's the sales amount? Here's the sales amount is a line chart and the date on the axis. And if I do the same here now, I can show you that the trend line is still working here. So trend line is working. And now if I add my, where's my new trend line? I forgot it. New sales amount linear. Here we're going. If we add this, now it is working. So I'm not sure why it's not working in the other case. The only difference, the small difference I was referring to is now this is expanded over the whole year. So there's more years available in my date table. And so we see like a forecast, a really simple forecast because it's a straight line. And with the stack statement, of course, we can influence now the calculation. We could change this to, we could do small changes and more complex changes. So if we take a look again to the measure, where's my DAX measure? Here's my DAX measure. So what we're doing here is, and this is not my invention, I took this from Daniel Malznick's blog, where he's also explaining how he came up with this idea, and I think he referred to other authors. So it was like a longer process until he or others came up with that. And I just took it from there. So thanks, Daniel, for blogging about that. And that's what I'm showing here. And the simple linear regression is rather easy to calculate. So you need the intercept. So the intercept is where the line is cutting the y-axis. That's the intercept. And then you add the slope times whatever you're showing on the x values. I'm showing the date on the x values. So for every day I have, for every date value I have, for every increase in the date values, I increase by the amount of slope the value showing on the y-axis. So this is rather simple. It's really simple, simple in that regression. I think this is rather understandable how the formula looks and how it is working. The more complex thing is how to calculate in DAX the intercept and the slope. And that's what we're seeing here. So the intercept, again, and variable here, is calculated, and that's the common formula, average of y minus the slope times the average of x. As easy as that. Now we need again the slope. How is the slope calculated? The slope is showing here. The slope is a division. So like this is like the upper part on the division line, and that's the lower part. So I'm dividing the number of items times the sum of x times y minus the sum of x times the sum of y, and so on and so forth. And these elements you can see up there. So this is really modular build, and now you can see this is really easy to read. Think of having everything, all those calculations in this element. Then the whole formula, I think, would be rather hard to read. And we also see that the slope is used 2 times. One time it's used in this end formula, and one time it's used in the intercept. So we would repeat a lot of stuff not having variables. So variables are a really good invention here. Where all the numbers are coming is known. So known is what we have as actual values. So what we're getting here on, Daniel is creating here a table named known with the select column function and putting the date and the sales amount there. And this is the numbers we're getting. And of course, we can influence this formula now. So if you're thinking maybe we do not want to see the calculation for the whole period, but only for the last part, then we can calculate, do our calculations, not for the whole part, but we're putting in a filter. So I want only see the linear regression line for dates greater or equal to the 1st of this January of 2013. So we only get it for year 2013. If I press enter and remove the formula here, we should see that now the trend line is only starting in 2013. I still see the dashed line here. The dashed line is coming from the trend line. We can turn off the trend line. We don't need it anymore here. So come on, open up that. I get rid of the trend line, and we see now our calculation only begins in 2013. As we're doing that, maybe it's also a good idea to calculate it only for the values greater or equal than 2013, so it's more accurate. And of course, we can also do that. I was prepared for this question. So we can add a filter here. So filter and remove the all selected. So now the calculation, the known values are also selected and filtered only for values greater or equal than 1st of January 2013. And if you're doing that, please don't blame me, because within the year 2013, the trend is not looking so good. So within the year 2013, we have a downwards trend, but never blame the messenger. So this is what we can do here. We can do the very same thing, of course, with R. So maybe you're okay with a simple regression line. Maybe you're okay with writing complex DAX, but maybe you see limitations in DAX and you see limitations in the automatic thing. Then you can come up with scripts, for example, in R. So have another thing here. Nothing slow here. And again, I could even duplicate this, I guess. Duplicate the page. Maybe it's faster. Remove this one. And then I remove my calculation from here. But change my visual from a line chart to an R visual. So I guess everybody has discovered there's an R script visual and there's a Python script visual. So we can use script written in R and in Python within Power BI. Please take care that, of course, you need a local installation of R, which is then used by Power BI. And it's also a good idea to have some IDE like the R Studio installed, so you can write your code, because you can write code down there, but maybe it's easier in a thing like R Studio. I try to avoid coding here. I usually open up R Studio and then pasting back the code here. So one thing we can use is, again, an R script, a regression line. And what I'm using here is the profit package and ggplot. So I'm passing in again, like I did previously, pressing OK here. Then we see the result, and then I think it's easier to discuss what's happening here. So what's now happening here is that I get an error. This is not very good. Unexpected in expression holds. Okay. So maybe I passed it too much or too less in here. That's interesting. Here we go. There's a different thing here. This is the regression line. Yes, that's what I'm looking for. We do not need profit at the moment. So paste too much of code. Then we see a similar line. So again, in green, we see the, let's make this a little bit smaller. In green, we see the actual values, and the blue line is the regression line. Again, as we can see, or remember, this is a simple regression line. How did I come up with that? So in R, what I'm using here, if you open up an R script, then it will tell you, it automatically passes in this code in here and telling you that Power BI is injecting the values like the date and the sales amount, as we can see here. So this date and the sales amount is injected into the R code as a data frame. So this is only a comment. I can delete the comment. It's only explaining what Power BI is doing for me. So in my R script within Power BI, I always have a data frame called data set, which consists of the values coming from Power BI. And this can also be really interesting for data scientists, because cleaning up the data in R is nice in script, but cleaning up data in Power Query is even nicer. So you could do all the cleanup jobs in Power BI and then use R running here within Power BI to use all the visualizations you have at hand in R. And then I have my thing here. I then rename the dataset because I already had a script running, which was referring to data frame called factory reseller sales. So I was lazy here, just renamed the thing and then copy and paste the rest of the stuff without changing. What I'm doing here, if you're new to R, I'm renaming stuff here. So the call names function is returning column names, and then I'm overwriting those columns name with new names. Order date and sales amount, I'm only doing this to get rid of this dot here, of this space here, and renaming the date to order date, because that's already a header script which is using this. Then I'm removing everything which has no order date, and then I'm converting, making sure that the date is really a date readable for the next things I'm doing here. So POSIX is a date format. And then I'm using heavily ggplot2. ggplot is a grammar of graphics, a package which you can install in R. So this is the cool stuff with R. Not the probably not the language itself is so cool, but the possibility to enrich the language with a lot of libraries. Last time I checked was in November, and then we had 13,000 packages available. So 13,000 packages. Many academics are providing scripts and packages to R, so you can use the state-of-the-art algorithms and stuff in R. So ggplot is then plotting my factory reseller sales. I'm putting the order date on the x-axis, on the y-axis the sales amount, and then I choose the color 3 for a line. So we get a line here and points. So see when the data is changing. This is the green line we're getting here. So color 3 is green. Then I'm increasing the text size to 18, so it's easier for you to read. I change the scale on the y-axis to continuous and fix it to between 0 and 5 million. So we get a fixed axis here, so nothing is changing according to the values. If I select something, the axis stays the same. And comma, it's not the scientific notation, but the comma notation. No legend, so the position is none. Labels, order date and sales amount on the axis. And this is what I did to get the blue line. I added a smooth line. Start smooth is part of the ggplot package, and LM is the linear model, the linear regression, the easy regression, and the confident interval I turned off here. Of course, I can remove this, then we get even a confidence interval. How confident this calculation is. In the middle, of course, is more confident, or we could just change it to anything else, like a local regression, for example. This is also built into ggplot. And of course, there's many of those 13,000 packages are also able to calculate something for you, which you can then do. If you think this is a better fit for your trend line, then use this. You can come up with complicated scripts like that, but it could also much easier. So for example, if I choose something like here, so discount, freight, the order quantity, the product standard cost, the sales amount, the taxes, the total product, the unit price, and so on, and put this in a table, and also put the date at the very first, and because Power BI is always aggregating values. So now we're seeing like one line of data. If I put in the date, like we see this per day available to those values. And if I look at those numbers, I could maybe see, yeah, is the discount amount is high here, the freight is lower, then I decrease the discount amount, the freight is going up. Maybe there's a correlation, a negative correlation between discount and freight. But is there? It's really hard. I mean, reading those numbers does not get anything for me, I would say. It is really hard to see numbers in here with the table like this. What we can do is, put this down here. Come on. Where's the red line I'm looking for? Here's the red line. So I'm copying this, pasting it here. So one thing we can do is that I use the correlation plot for that. So there's now on the marketplace, on app source, there is a custom visual available. So this is not pre-installed with Power BI, but you can add it. So you just press the ... there. Then a dialog is opening up asking you if you want to have it from app source or from a file or to remove a visual. And if you choose app source, there is, I never counted them. There's a lot of visuals out there by Microsoft and third parties. So please take care. This could be code running from third parties. I would recommend to watch out for those blue signs here. This means that this visual is certified by Power BI. So someone from Microsoft did overlook the code there. So this code is not harmful. This code is not sending anything else outside of your Power BI sandbox. And this, for example, has a lot of smart visuals. And one of the smart visuals would be the correlation plot, or there is like time series or radar chart. So some of them are indeed using behind the scenes using R. And the correlation plot, I know for sure, because this is in the description, is using R. So if I change this to a correlation plot, we get a correlation plot calculated in R, but without the need of writing any R code. So you can use R even without writing any code. And what is this correlation plot showing us? This is showing us all those columns I selected on the rows and on the columns. And then we get this blue dot in between because there's a really strong positive correlation between the discount amount and the discount amount. So everything with itself, of course, has a strong correlation. This is the blue dot, the big blue dot, and dark blue means a correlation of close or even 1. On the other hand, we have red areas. Red is a negative correlation. The darker the red is, the stronger the correlation is. So between the unit price and the order quantity, no surprise, I would say, there's a negative correlation. The more expensive a product is, the less it is ordered by our customers. This is no surprise, I would say. We can build the same chart. Again, if you're satisfied with that and all the options it's giving you, so there's some options you can change here in the format options. So how to calculate the thing here. If this is not fitting your needs, then of course you can come up with your own calculation. So let's maybe put this down. Let's change a little bit of spaces here. Come on. Let's put this down. Let's put this up here. Yes. Come on. Oh, thick thumbs here. So we can again change this to an R visual. And this R visual, very good here. So first select the visual, then change it to an R script. We can write R code. And this R code is so simple that even I can just type it in. So there's a library called correlation plot, core plot. And for the dataset, I use the dates in the dataset only to get several values of date. If I would not do this, then it would automatically aggregate the values. But for the correlation, I'm not interested in any correlation about the date. So I can remove this. So I would put in the data set, and then I remove the first column. So -1 is the second parameter here. And then I write core plot of the correlation of my dataset. I hope I did not have any typo. If I'm using that, we should get a similar thing here. I had a typo of the core could not find function core. It's core with only 1 R. So let's change it and run it again. Then we see a very similar chart to what we have seen in the smart visual coming from the custom visuals. And again, we can do the same also. That's what I want to show you in Python. So you can also change this to a Python chart. And then the code in Python, at least the code I came up with in Python, is a little bit longer. Python, so let me find the code for you. So I will not type this in. Again, we are using packages, libraries there, and passing in the Python code here. And run this. Then we get a similar correlation plot. This looks a little bit different like the other one. Again, I have some typo in here. Correlation plot, yes, of course. At the very first line, this is not code. I only need the part from here. So the numbers are the same. The information we get from this plot is the same, but it looks a little bit different. So again, we have this blue areas there showing a strong correlation between the things, and negative correlation between the unit price and the order quantity. And then, of course, you can play around because this is a script now, and now you can change anything you want as long as you know how to code this in Python. How are we doing time-wise? 5 minutes to go. Are there any further questions so far?
Thank you, Markus. Not Not many related to this, but there was like one
Yeah.
question like how do we know which technology or algorithm is used behind the scene of AI visuals, which I guess is different for each visual, right?
Yes, it is. This is not very well documented. So if I'm going back to the app source, let me open up that. And we're going, for example, to the correlation plot. Uh, correlation, I think this should make it. Then we have the correlation plot here. If I not add it, but I click on the text here, we get some information. So there's a description and we show more. It's revealing a bit of the thing. It's explaining what is a correlation plot, and it's also showing up that it is using, where is it? It's using an R package core plot. So this is the same package. So can everybody read this? Maybe zoom in here. So it's using the core plot package. Of course, the core plot package could have several algorithms to calculate the things. That's not revealed here. What some of those visuals are they are open source, so you can get to GitHub and then dig into the code there. But like if you do not want to dig into the code, it's hard to find out what kind of algorithm this is used. Again, I mean, there is no good or bad algorithms. If it's fitting your needs, if the numbers make sense, what is coming up with, that's at least a good starting point. And maybe then you learn later that there's some improvements possible. Then you have to get your fingers dirty then in R or in Python and improve the thing here, or reach out. Of course, there's a consultant available which can help you in tuning all those things in R and Python. So
Great.
just wanted to show you this, like from GUI to using smart visuals, which are using R, to writing your own stuff. This is like what my goal was to show you.
Great. Awesome.
Questions
Thank you. And I guess we are up at our time. So if you want to wrap it up, that would be great.
This is a good time now to wrap it up, I
Yep.
guess. There's a lot more I could show you, but yeah, time-wise, it's always hard to get everything into 60 minutes. So the rest of the slides is just summing up what some parts I did show you up with all the links to the documentation. So if you're interested in Q&A, there is the link for you in the docs and a short summary what this feature was. This was like the double clicking and then I just entered the text. The insights feature was the thing where we ask for, please explain me the increase, please explain me the decrease. This is possible in several visualizations. Again, the link is out there. Then I did show you the what if parameter, where we have the possibility that the user changes a value within an area and we can refer to this value within DAX. We can refer to this value, of course, in our visuals. We can show the value, and of course, we could also, would be a more advanced thing, ingest this value into an R or Python script, and then the user has the possibility to change things ad hoc, which is not coming from not values coming from the model or from the data, but like setting a certain value to a certain parameter to a certain value, which we're then using in our scripts. The analytic line I showed you for the trend line and the max line, and we can build the analytic line, of course, also in DAX or in R, depending on how advanced your calculation has to be and how you're satisfied with the outcome of the standard analytic line. I did not show you the cognitive services. This is a possibility to reach out to Azure services like key phrases. I have example where I send texts and then I get the key phrases back. So all the and to and the common words are removed. I only get the key phrases and then, for example, build a word cloud on it. You can see it in the Power BI file, which I will provide to you. And then you see how you can get in the parameters to the Power Query. And again, a more advanced thing would be the Azure Machine Learning Services, while cognitive services pre-trained. So somebody at Microsoft trained this. I mean, not somebody, a whole team of data scientists is taking care of the cognitive services there. But you could build your own models, again, in Azure Machine Learning by using components provided by Microsoft, or, again, running R and scripts in R and Python, and then make your own web service, which you can then use in Power Query, for example. As soon as you refresh your data, you call out to the Azure Machine Learning Services or in any other application. So you could build a web application, which is then using the insights getting from the machine learning. There's also two cool features. The column, by example, R integration. Yeah, I did show you this only as the visual, but we can also use this in Power Query as a source and transformation. The same is true for the Python a source transformation and visual. And key influencer visual, I did not have time for that. I did not have time for the composition tree. There's so many things happening there. Please check out all those features. And the cool and funny thing is the web example, the column example, where you do not write your own Power Query or your own Power Query, but type in examples. So you have like a list of values, and then you only type in the first name, and then automatically it would get the idea that you're interested in the first name of the full name, and provide you with an M code, which is then extracting the first name, for example. This is a really cool feature, which makes it much more easier to start with Power Query instead of learning the M code firsthand. Yeah, Docs is your friend if you're interested in things. And of course, I have this masterclass here, but this masterclass is not happening now. So I have to remove this slide again due to the current situation. And if there are any questions, please use the comment functions in YouTube if this is enabled, or reach out to me on Twitter or LinkedIn, and I will be glad to get in discussions with you.
Great, thank you. We have one question from Christian. Have you tried to do any custom visual using Charticulator? Or I guess the question is like, is it possible to do something like that?
Yes, it is possible. So there's this tool from Microsoft Research, if I remember correctly, called Charticulator. I think the website is like charticulator.microsoft.com or something like that. I have to look it up. I don't remember it exactly. And this helps you in building your own visualization. Really smart tool. And if you like this visualization, you can then convert this into a custom visual, which you can then load into Power BI. So with the help of this Charticulator, you can come up with really, how to say, complex or really new innovative forms of visualizations. I don't have a demo right here, but yes, the short answer is yes. If you use Charticulator, you can then transform it into a custom visual, and you can use it in Power BI. Are there any more questions?
Great, thank you. I guess that was like all the questions. Thank you for your time again in the bedtime, let's say. You dedicated your time for this. I guess we need to have like more sessions like this. You have so much content, so we need to schedule something later on. And thanks everyone for attending.
Thanks for having me, and bye-bye, everybody.
Thanks, bye.